Right, in this video I'm going to show you how to do simple calculations of DC circuit questions. Now first and foremost, let me just get my pointer, or in fact my pen ready. So this question was the one which I used to start off the module, if you remember, and some information given here would be that the current over here is 0.2, which means to say that throughout the whole circuit the current flows through as a 0.2 ampere current. The question over here, part A, asks about potential difference across between P and Q. So what it means is that if I have got a voltmeter over here, and let's say that this is V1, and over here if I've got another voltmeter, and let's call this V2, and this being the EMF, I'll call this E. The relationship between these two will be as follows. E is equals to V1 plus V2. Okay, so there are some knowns and some unknowns. The EMF is known, and it's 24. V1 is the potential difference across P and Q, and therefore is unknown, plus V2. V2 will be equivalent to I times R. So the I will obtain from the current over here, and R will be the resistance of this resistor. So I and R will be calculated as 0.2 multiplied by 80, and that will give us 16. Right, so this will be 16. So answer, we're getting it very soon, is 24 subtract 16, that will give us 8 volts. Sorry, so 8 volts. So this is the answer. Okay. Next, what is the current flowing through R? So the current flowing through R over here can be determined if we know what is the current flowing through the 50 ohm resistor. Now take a look at the 2.2 ampere current. This current will flow through the entire circuit until it reaches this point. At this point, it's going to split into two parts. One part goes here, which is through the 50 ohm resistor. Another part flows here, which is through the 40 ohm and the 40 ohm resistor and resistor R. So if we are able to find out what is the current flowing through the 50 ohm resistor, all we need to do is to subtract it away from the 0.2. Then we will be getting that. So in short, it means this. Right, the current through the 80 ohm resistor is equals to the current through the 50 ohm resistor plus the current through the R. So the current through R or the current through 40 ohm resistor is actually the same value. Okay, so current through the 80 ohm resistor as given by the question is 0.2. Current through the 50 ohm resistor can be calculated using V over R. So the V over R over here, and then plus what is the current flowing through IR, which is the unknown. Now V over R, let's bring this out. Right, it will be 8 ohms. Right, 8 ohms as calculated just now, PQ. So 8 ohms divided by 50. Okay, so IR is equals to 0.2, take away 8 over 50. 8 over 50 is actually 0. Let me just use the calculator. 8 divided by 50, that will give us 0.16. Right, let me just indicate over here is 0.16. So what have we got is that 0.16 current through resistor R is 0.04 ampere. So this is the answer. Okay, so right now we know what's the current flowing through R, and the last part asks for the resistance of R. Now the resistance of R can be determined now. Okay, so let's just take a look. Let's consider the whole branch over here. the whole branch over here. Okay, the effective resistance of these two will be 40 plus R. Okay, so resistance, or in fact the current through this loop over here, which is equivalent to IR, is equals to V over R. And the V over here is 8 as calculated in part A, divided by the resistance. Now the resistance is a combination, or in fact is an addition of R plus 40. So I'm using R quite often, and you know, sometimes it might cause a bit of confusion. So basically this one is the resistance of resistor R plus 40. So this whole thing should be equal to 0.04 ampere. Okay, so this whole thing over here, solve for it. This whole thing over here, solve for it. Shouldn't be difficult. You'll be able to get the resistance of R over here.